Alright, my dear children, now we try to understand and define first law of thermodynamics. Okay, now to state the first law of thermodynamics, let me just go back to the relation which was derived by James Prescott Joule. Now, according to James Prescott Joule, as you know, there is a relation between work and heat. Okay, the amount of work done and the heat which is produced is actually given by the relation W equals to JQ. See, this is the relation that we have already learned in details, and this is the relation which was derived by Dr. James Prescott Joule. Okay. Now, if you look at this relation, it is the relation between work and heat. W is the work, Q is the what? Heat. And in this expression, you know that J means what? Also called what? Heat? Mechanical equivalent of heat. This is called mechanical equivalent of what? Heat. Okay. Now, this equation means that whenever a certain amount of work is done, an equivalent amount of heat, that is Q, is produced. When certain amount of work is done, equivalent of heat is what? Produced. Or by using a heat, say Q amount of heat, which is applied on a body, equivalent amount of work can be done, or equivalent amount of work can be obtained. That means work and heat are always related to, is given by the relation that is W equals to JQ. And the relation between work and heat is actually the study of what? Thermodynamics. Okay. So, in order to state the first law of thermodynamics, the first law of thermodynamics statement is based on the relation between this amount of heat applied on the body and the work obtained on the body. Okay, that means the relation between heat and work in the form of internal energy. Let me tell you, in the form of what? Internal energy can also be stated by the first law of thermodynamics. So, the first law of thermodynamics give the relation between heat and work, but in the form of what? Energy also? Internal energy. So, first law of thermodynamics has a statement. So, statement of first law of thermodynamics. And the statement of first law of thermodynamics say that if some quantity of heat, and say that quantity of heat, say Q, okay, is supplied to a system. There is a system, okay, in which we are supplying heat. How much amount of heat? Q amount of heat to a system. And that system can able to do some external work. Then that system can able to do some amount of external work. Then the quantity of heat will be absorbed by the system. So when you are supplying heat to the system, means that system absorbs some that same quantity of heat. Okay, then the quantity of heat absorbed by the system is equals to the sum of the increase in what energy? Internal energy, that is delta U of the system, and the external work done, that is W by the system. So the statement of first law of thermodynamics can be written mathematically as Q, the amount of heat. Suppose you are applying Q amount of heat to the system. So definitely that system absorbs same amount of heat. So this amount of heat absorbed by the system is utilized to increase the internal energy of the system, that is delta U, plus, and that system even do some external work done by the system, and that work done by the system is what? W. That means Q is always equals to delta U plus W. So this is the mathematical relation or statement of what? First law of thermodynamics. So the first law of thermodynamics simply give the relation, as I said, between heat and work, but even in the form of what? Energy? This internal energy. The change in what? Energy? Internal energy. Means whenever a system absorbs Q amount of heat, then that absorbed heat by the system is utilized by the system to increase the what? Internal energy of the system, and the rest of the energy is used to do some amount of work done by the system. So definitely there is when the amount of heat is applied, the work is done by the system. Okay, so that means Q equals to delta U plus W. So this is the mathematical statement of first law of thermodynamics. But children, first law of thermodynamics can be written in differential form. Can also be written what form? Differential form means that form where the change of this quantity, like internal energy, even the work done and the the amount of work done, the heat supplied, are very small, and this change is called infinite small change. And you know, in case of calculus, if there is a very small change, and that change is expressed by differential form. Okay, now differential form. So that's why if in a process, if an infinite small amount of heat energy, that is dQ, is given to a system, See, Q is the amount of heat energy supplied to the system, no doubt. But if dQ is the amount of heat energy which is supplied to a system, which is very small amount of heat, even if you supply to a system, then that system absorbs this amount of heat. And this absorption of heat, small amount of heat absorbed by the system, is utilized by the system to increase a very small amount of work done. Okay, to do the work done by the system, and that work done is also very small, that is dW. And due to this work done, there is a small change in what energy also? Internal energy. So if there is a very small change in internal energy of the system, and that I write down as dU, and dU is what? Infinitesimally small. Infinitesimally small change in what energy? Small change in what energy? Internal energy. Change in internal energy of the system. So under this case also we can write the first law of thermodynamics as dQ equals to du plus dW. So look at the relation. In the previous relation it was Q equals to U du delta U plus W. Now in this relation you see it is dQ equals to du plus dW. Now this is also the equation of what? Or the statement of first law of thermodynamics. But this particular relation which I have written, okay, is actually the what? The differential form of first law of thermodynamics. Okay, that's why if it asks in the examination to write the differential form of first law of thermodynamics, means we write this relation, means dQ equals to du plus dW. Okay, now if dQ equals du plus dW, then I can make du as the subject. Then du equals to dQ minus dW. So if I take dW in the left hand side, it's minus dW. So du equals to dQ minus dW. So this is the differential form of first law of thermodynamics. And children, one point you need to keep in mind that in this relation and the relation that we done, that is Q equals to delta U plus W, okay, both are equation, mathematical equation of what? First law of thermodynamics. But in this equation, all the quantity, that means Q, delta U, W, all the quantity should be taken with the same unit. All the quantity should be taken with the what? Same unit. Because heat, internal energy, change in the energy, work done, all should be taken in the what unit? Same unit. Whether you measure in joule or in what? Calorie. Okay. Now the next part that also need to keep in mind, if heat, some amount of heat is absorbed by the system, if Q is the heat which is absorbed by the system, then this heat should be taken as positive. If this heat is taken as what? Positive. But if Q amount of heat is released by the system, is given up by the system, then that heat will be taken as negative. That we have already done the sign convention. Similarly, if this internal energy is increases, if change in internal energy means increases, then that energy is positive. If this change in internal energy decreases, means that energy will be negative. Similarly, if this work is the work done by the system, then that work done is always positive. If this work is the work which is done on the system, then that work done is always what? Negative. So children, remember this part. In case of thermodynamics, first law of thermodynamics, we have to follow the proper sign convention depending upon the situation, whether the system absorbs the heat or given the heat, or whether there is an increase in internal energy or decrease in internal energy, or whether the work is done by the system or work is done on the system. Okay, this part is very important. Okay, now the next thing that I want to give you information is that first law of thermodynamics is actually the another form of law of conservation of energy. So this point also you need to keep in mind. First law of thermodynamics. Okay, first law of what? Thermodynamics is the what? Is another form. This is another what? Form of law of what? Conservation of energy. Conservation of what? Energy. That means the first law of thermodynamics simply follow the law of conservation of what? Energy. So children, one point you need to keep in mind, that what is the most important significance of first law of thermodynamics, means the first law of thermodynamics express the relation between heat and work. That is important. Okay. Now this law even signifies that heat can only be produced at the expenditure of some amount of work or some other form of energy, and that some form of energy in the form of what? Work. That means heat can only be what? Produced at the expenditure of what? Some other form of what? Energy. This means we cannot make a machine with we cannot make the machine, okay, with perceptual motion, or we can simply use the word like we cannot get work without spending energy. Simple statement. Let me tell you that we cannot get work without spending energy. So without spending energy, work cannot be obtained. Okay, so this is a concept of what? I mean the basic significance of first law of thermodynamics. But other than the significance of first law of thermodynamics, children, there are some limitation or drawback of first law of thermodynamics. So in case of limitation of first law of thermodynamics, okay, one of the important limitation is the law does not tell us anything about the condition. This is important. Does not tell us anything about the condition under which the body can convert heat into work. Now this simply gives the relation between heat and work. But under what condition this heat is get converted into work? That condition is usually not explained by the first law of thermodynamics. Okay, so the condition cannot be explained by the first law of thermodynamics. So it simply gives the relation between heat and what? Work. Next, it does not tell us the direction in which the change takes place. If there is a change in internal energy, or if there is a change in what? Some other form of energy, okay, then this change, in which direction the change takes place, that cannot be explained by the first law of thermodynamics. That's why it does not tell us the direction in which the change takes place. And lastly, it says that it does not give to what extent the change can take place. That means the first law of thermodynamics even does not explain or gives up to what extent the change of this internal energy can take place. So that cannot be explained even by first law of thermodynamics. Although first law of thermodynamics is another form of law of conservation of energy, it gives the relation between heat and work, and this law simply says that without doing some external work, heat cannot be produced. Okay, but even that, there are some limitation of first law of thermodynamics. So these are the detailed explanation of first law of thermodynamics, statement of first law of thermodynamics, significance of first law of thermodynamics, along with that, the limitation of first law of thermodynamics. Now, in the next YouTube video, children, we learn some important processes. There are some important processes in which the first law of thermodynamics can be defined. Means we learn the application of first law of thermodynamics.